All right, first we're going to share a screen. There we go. All right, we are looking here at number 1 from 541, and we are looking at similarity, triangle similarity, and here are the options for 541. In the last section, we learned about AA, angle-angle criterion. Here we need side, 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 or side, angle, side, okay? So if I look at this, number 1, it's saying prove that the triangles are similar, okay? So here's the thing. We can't go up here and say, oh, it's definitely satisfying this, so I know it's similar. I can't go in here and say, oh, it's definitely satisfying that, so I know it's similar. We don't know, because what information are we given? We're told the lengths of the sides for these two triangles. We're only told that one angle is in common. There is no similarity postulate that is just, well, there's one angle in common, because that doesn't mean anything. One angle doesn't help. Oh, look, I have an Instagram notice. All right, that's going to happen. Sorry. Down the way. All right. So we're going to prove that these triangles are similar. And if I look at that, what do I need to do? I need to do the same process as before. So we need to find our corresponding sides here. Now think about this. This angle is the same, and our sides are right next to on each side of the angle for both of them, okay? But if this is truly a similar triangle, then look, the larger value, 14, is going to correspond to which one of these? The lower the larger value. The larger value. 14 and 5.6 correspond. 13.5 and 5.4 correspond, because this is larger than that, as that is larger than that value, okay? So basically, because we have to prove the triangles are similar, we need to just create our same ratios, proportions, that we would if we would have gone and said, oh, check, these are obviously similar. We would do that process. We don't know if they're similar. So we're going to assume they are, do the same process we would, and see if it works out. So watch. I'm going to go 14, which corresponds to 5.6. I'm going to go 13.5, remembering that the same triangle has to be on the numerators or the denominators. So since I put 14 on the top, I have to put 13.5 on the top. Okay, corresponding parts, same triangle. Okay, so here we have 5.4. Okay, so what I'm going to do here is I'm going to make it a little bit easier. I'm going to do is just take these numbers. I'm going to go 14 divided by 5.6, and we'll get a decimal. That's 2.5. Now, what value do I need to have over here in order for us to know this is similar? What value do I need to have over there to know it is similar? All right, look at that. I need to have 2.5. 13.5 divided by 5.4 is 2.5. 14 divided by 5.6 is 2.5. So because the ratio between them is exactly the same, we know that these are similar. They're similar. We don't know which criterion would prove that, right? But what we do know is that if the proportion works out, then we know it has to be similar. All right, let me just take a peek over here at number 2. Yeah, it's the same thing. Okay. All right, I'm going to pause this. All right, here we are. We're looking at number 3. Number 3 in the workbook. Let me pause it 1 sec. Oh, hello. Hello, phone. We like it when you work. You don't shut off. Ay, ay, ay. All right, we're back. So we're looking at number 3 here, 5.41. Now, again, we need to prove that they're similar. So when we're proving that they're similar, we can't find our options first. We can't go in there and say, well, it's definitely similar because of this, this, or this. I do know that this angle is the same for both triangles because the smaller one fits in the larger. And that's the same vertex form. What else do I know? I don't know if these are parallel. That would help me out. We'll learn that next few lessons from here. So I don't really know which criterion would work. So what I'm going to do is, first, just go ahead and find your corresponding sides. So 5 corresponds to 7. So I'm going to start off by making I'm going to do the small triangle on the top, the larger triangle on the bottom. So with that, I need to look at the smaller triangle has 5 on the top and 7 corresponding to the larger one. You see this triangle is inside the larger triangle, okay? Now here's another thing we need to look at. So I know that this is 6.25. This side over here is 2.5, but I'm relating the smaller triangle, 6.25, right? And I can even write that in there, 6.25. I'm relating that to the entire length of that triangle, which is 2.5 plus 6.25. So this is 8.75. Okay. Now we're going to go and do our trick. We're going to go in and just see if these proportions are equal. If they are, then we know it's similar. And let's go ahead and use our calculator for that. And it's still here, yay. All right, so look, 5 divided by 7. This is going to give us 0.714. Let's leave it like that. Let's see if that's equal to, and if it is equal to, then we know it's similar, okay? So let's go, let's see, 6.25 divided by 8.75. Oh, look what we got. 0.714. All right. We know that these two proportions are equal to each other, so the triangles are similar. All right, guys, we're here, same lesson, number 4. Here, maybe you're starting to get an idea. Maybe you're getting an idea on what postulate this might be. So we had AA, we have SAS, we have SSS. It's always going to either be an angle or a side. But here I know that it's side, side, side. That's what I'm going to try to assume because, look, we have information about all the sides, okay? Now, in looking at that, we have to see if the corresponding sides have the same ratio. For instance, if 6 and 12 were both corresponding, or 6 and 9, 6 would grow to be the same size as 9, as 8 would grow to be the same size as 12, as 12 would grow to be the same size as 18. So I've kind of done that for us. I've corresponding the sides. I know that this angle is the largest, so across from it has to be the corresponding side. Let's see. And then based on the drawing, which isn't perfect to it, but how is this happening every time? I have to pause it. It's driving me crazy. All right, guys, we're going to have problems with that just because my phone battery's a little low and I can't turn the auto lock to last longer than 30 seconds. So it's going to be great. All right, hopefully it keeps on taking my focus so that it stays on. All right, we had 18 and 12. We're going to have 6 and 9 related. We're going to have 8 and 12 related. So all I need to do here is I need to create 3 fractions. I'm going to go with, let's see, I'm calling this the larger triangle, this is the smaller triangle. I know it's not drawn very well. But let's put all the larger triangles on top, smaller triangles on bottom, values. So we're going to put 18 and 12. Okay. We're going to put, let's see, larger triangle on top, 9 and 6. And we're going to just see what these equate to see that they're all the same. Then we're going to put, let's see, a larger triangle on top. So corresponding is going to be 12 and 8. Now let's see what all these equal. This one here, I know it's divisible. These are both multiples of 6, so we have 3 halves. These are all multiples of 3. We have 3 halves if we divide all by 3. This also is a multiple of 4. If I reduce this, I could divide by 4. Just reducing it, we'd get 3 halves as well. So because the scale factor is 3 halves, that's all the same as 1.5. We could say that this larger triangle is 1.5 times larger than the smaller. So this is called the scale factor, okay? The scale factor is going to be 1.5.